All right, today's lesson's on 6.8, graphing radical functions. This handout is on a Google Classroom, so there's quite a bit of graphing here, so it's just nice to have a handout for these notes. But we're going to recall the transformations that we did with absolute value functions, y equals the absolute value of x, and y equals x squared. For those translations of radical functions will be very similar. So this is your general form for a radical equation where that a, the h, and the k all mean something. So the h that is on the inside of your radical, that is going to shift it horizontally. So it would be going left or right, and it will go left if it says plus and right if it says minus. Just like when we had this meant right 3. Okay, the k that is outside of your radical and it's either adding or subtracting is going to move your graph up or down. If it's plus, it goes up. If it's minus, it goes down. So this would be right 3, up 4 for those translations for a quadratic function. This is of the parent function, y equals a times the square root of x. The value of a would determine a reflection, stretch, or compression. So if we have a negative, we've got a reflection. If you have a number that's larger than 1, that would be a stretch. And if you have some kind of fraction or decimal, that would be a compression. All of that is from the first quarter when we talked about different transformations. So our parent most basic function would be y equals the square root of x. So let's go ahead, make a little table, and sketch a few points for this graph. Now think about what we're plugging in, okay? I can't plug in any negative numbers. Typically when you make your first table, a lot of times we pick -1, -2, 0, 1, and 2. The square root of -1 would be the imaginary unit I, so we're not going to use that. So the first smart choice to start with would be 0. The square root of 0 is 0. Another smart choice would be 1. The square root of 1 is 1. Now you can select 2, but the square root of 2 is a messy decimal, so I would select something that would be nice, like 4. The square root of 4 is 2. You could select 9, another perfect square, and get 3, but what you're going to find is we're already going to run out of space beyond 4 as my x value. So if I plot these, I've got 0, 0, 1, 1, 4, 2, and 9, 3 would be off of my graph, but you can kind of see what's happening. It's slowly making this arch, and it's increasing, where it's getting higher and higher. This is, if you kind of tilt your head to the side, this is just a sideways parabola, okay? So for my domain, we talked about domain and range in our last lesson. So all of my x values must be greater than or equal to 0, and all of my y values must be greater than or equal to 0, or we also talked about interval notation, 0 to infinity. Okay, so that's my basic graph. So these are the 3 points I'm going to be moving around over and over in our translations when we move on to the next set of examples. So in these next two, we're going to look at how are they different than just my parent graph. So what are those transformations that are being done, and then how that affects the domain and range and what the graph looks like now. So this is your general form. So my plus k is that minus 3. So it's a -3. So that's going to move everything down 3. So a couple different ways you can think of this. You can make your table. You can go ahead and plug in 0, 1, and 4 like we just did, and then subtract 3. You could make a quick sketch of your parent graph and then just move every point down 3. Or you could take the normal starting point, move it down 3, and then no, you go over 1, up 1, over 4, up 2 from that original parent graph table. So this isn't going to change my domain. X still must be greater than or equal to 0, but it is going to change the range because my lowest value for y is -3. So y must be greater than or equal to -3. Okay, for number 2, I've got my x minus 3 on the inside. Okay, so I set both these two up examples next to each other on purpose. They are not the same thing. One of those numbers up for -3 is inside the radical, the other is outside the radical, and that means different things. This is going to move it right 3. If you have forgotten these transformations, you are welcome to go ahead and plug in 0 and take 0 minus 3. That won't work. You're going to get a negative number. So it wouldn't work until you start using 3, because 3 is going to make it 0, and then we could start calculating. So you're welcome to make a table. It'll probably take you longer if you're not familiar with your transformations, but I'm going to use those since we are building off of things that we learned last quarter. So if I move everything right 3, that would be a new starting location. And then I can do the same exact pattern as I did before. And then I'll just make one more spot because it's going to be just a little bit off of my graph. So if I'm moving things right, now I just shifted the domain. Now all my x values must be greater than or equal to 3. And my range is y is greater than or equal to 0, because 0 would be the lowest y value. Our next two graphs, we're going to add on a few multiple transformations at once. So I've got the 2 multiplying out in front. That 2 is larger than 1. That is going to stretch my graph, and we'll look at what that does. So that's a vertical stretch. And then I'm going to go right 1, since it's on the inside, and then down 2. Okay, so if I go from the center, right 1, down 2, that is the new starting location for this graph. So typically, those would be the next 2 set of points. But now what's happened with this 2, if I kind of just ignore that -1 and -2, since I've already made those shifts, when you plug in 0, you get 0 times 2 is still 0. That's where I'm starting. If you plug in 1, the square root of 1 is 1. 2 times 1 is 2. So I will need to be 2 above the start. Okay, if I plug in 4, normally I go over 4 and up 2, but now when I plug in 4, I'll get 2, and then I must multiply that by 2. So I would go over 4 and up 4. So what's happening is, since we have that 2 in front, all of my y values are being doubled. That's what's going to make this stretch. It's going to make it more tall as a whole. So normally it was only 1 up, now it's 2 up from the start. Over here is only 2 up, now it is 4 up. So that distance in the y values has doubled. If I had a 3 in front, that distance would have tripled. Okay, if you're struggling with it, you can type it into Graphing Calculator and Desmos and kind of, picture that and get a better picture. You can also plug in numbers and start making a table. Okay, but my domain, x must be greater than or equal to, my starting x value would be 1. Y must be greater than or equal to, my starting y value would be -2. I am getting those values also straight from my equation. All right, with number 4 over here, I have a negative in front. That is going to be a reflection. I have a 1/2 in front, so that's a number between 0 and 1, and it is a fraction or decimal, which would be between 0 and 1. So that is going to make it a compression. Our last problem, we had a 2 in front, so that stretched it. So it doubled my y values. Now we're going to cut those y values in half. Okay. And then right here, I'm going to go left 2 and up 1. My left 2, up 1 gives me my new starting location. The reflection, so if this last problem on number 3 would have been reflected, that would have been what a reflection would have looked like. It would have flipped it over the x-axis. So ours is going to be flipped over with that negative, and it's also going to be cut in half. So if you want to visualize where it normally would be if I didn't have any stretches or any reflections, that's where my next 2 set of points would be. A reflection would move them there. So I'm going to take those off. So that would be if it was just reflected, if it was just a negative in front of the square root, but it's negative 1/2. So that means these values have been cut in half vertically. So instead of going a distance of 2 away from that starting value, I went down, I went down 1. Because I would be cutting the y values in half that I normally would have plugged in. So if I plug in 1, square root of 1 is 1 times 1/2. Technically, I should put the negative in front. So if I plug in 1, I'd get negative 1/2. So I'd go over 1, down 1/2 from my new starting location. My domain, x must be greater than or equal to -2, y must be greater than or equal to 1. All right, with Math Excel, you're really just going to be matching the graphs anyways. So, and you're going to be telling what the transformations are and talking about domain and range. That's kind of the big thing to get out of all this. So if you can come up with those things, if the exact points aren't quite working for you, if you understand the transformations, you should be able to select which graph would make sense. Okay. All right, the last part that you will see in your Math Excel assignment, you might be given problems like this where they say you need to rewrite the equation and then say what the transformations are. So if you have a coefficient or a number in front of x, we don't have that transformation yet. You need to factor that number out. So factor 4 out. Okay. In this problem, we're going to factor 9 out. And then that -4 is still on the outside. Right? Then you take a look at the number in front, or that number that you factored out. Every one of these is going to be a perfect square. So you're going to take the square root of 4 and bring that 2 out, and then you have x minus 6 left inside. Here you're going to take the square root of 9 and bring that 3 out, and then you've got your x plus 4 left inside and your minus 4. So now it's going to look like the equations that we were just doing. So what are my transformations? That 2 is going to be a vertical stretch by a factor of 2. And then that -6 is going to move it right 6. So we were not going right 24. That would be incorrect since there was a 4 that could have been factored out of that equation. And then same thing below. This 3 is going to be a vertical stretch by a factor of 3. And then inside my radical would move it left 4. And then outside the radical would move it down 4. All right, so that's a quick lesson on our 6.8 graphing radicals. I did go through those graphs pretty quickly, so please let me know if you are having any trouble matching your graphs in your homework. Good luck.